Okay. Guys, I'm so excited that there's so many new, young JavaScript Node people here. It's like super exciting. However, I hope this isn't like too much. Before we get started, my name is Cory Brown. I tweet very rarely at these two places. I tried to make this my New Year's resolution to tweet one JavaScript thing a day, and I got to March, which was pretty cool. And then I'm radio silent. But I'd like to get back into it. So if you guys want to see more and you follow it, you're like, hey, how about something about this, just to remind me. But whatever. It's fun, but it's whatever. I work at Nav. We're a financial technology company, fintech company. We're helping small businesses get financing. It's a lot of fun. I love it. And that's me. So hopefully today, you're going to walk out of here in less than 15 minutes, you will understand monads. So here's the two big questions. Who has not heard of a monad before? Oh, okay. That's all right. Who's used promises? You familiar with promises? Yeah. Okay, more or less. You don't have to be an expert, but you get the idea, right? Okay. A monad is a functional programming paradigm concept. Okay, and it's interesting because you already know. Oh, my mouse is in the way. Yeah. Thank you. Somewhere over here. There we go. I'm proposing that if you know promises, you already intuitively understand monads. And even though you don't know what a monad is, you'll run into it, and people are like, oh my gosh, monads, they're so hard. And be like, no, actually, here, let me explain it to you. It'll be great. Here's why that's super interesting. Because monads are famous for being cursed. It is often said that once one understands what a monad is, one loses the ability to explain it to others. So, and that ends up becoming something of a self-fulfilling prophecy. People think that it is, and so therefore they're like, oh crap, now I don't know how to explain it. And the problem is because everyone that teaches it on the technical level. And so you have to first learn all these big words in order to use those words to define it. That's not what we're going to do. So, we will start out with the technical definition first. The technical definition, a monad may encapsulate, let me read this over here because that's weird, may encapsulate values of a particular data type, creating a new type associated with specific additional computation. Obvious, right? So if you have a string, right, a string data type, then we can encapsulate that with some additional functionality and produce a monad string. Obviously. Right? Done. Okay. I was challenged to walk up here and say a monad is just a functor in the category of endofunctor. So done. Which is how you typically learn this, which is gobbledygook to me. So I'm not going to do that. So let's start basically. Suppose you have a string. So far, so good. If I get too weird and complicated at any point, stop me and let's cover it, okay? But let's suppose you have a string. And we assign that string to a variable. Any old schmo coming along can use that variable use the value by referencing the variable, right? As long as it's in scope. Suppose that we want to protect this value, though, and keep it safe from prying eyes or other derelict ne'er-do-wells. We could, one way we could do that is put our precious value into a box or container of some kind. Okay, so it's not just exposed out there like a weak child. For our purposes, we'll call this notation our container. Forget that it's an array for a minute. It's a container. Yeah. I don't want to clutter it with the other aspects. Okay, all right? It is just a generic container. So we're going to take our string, our little value, and we're going to put it safely inside this box, in this container, as indicated by the boxiness. Okay. Now suppose we have a function. And the purpose of this function is to act on a string somehow, right? It's just a standard function, nothing special about it. This just gets the length of a string. Regular function. Will this work? No, it won't work. Our function, who deals with strings, has no concept of a container, right? So, fortunately, our container does know how to take its value and hand it to a function. It does so only when the function comes to it and asks politely, so that there's no shady abduction of these values going on. The container knows how to give the value to a function, or a container that knows how to give a value, its value, to a function is called a functor. Weird word. That's what it's called. You'll hear that word later on too, probably. Functor. A container that knows how to give its value to a function. This works. And this works out of the box because arrays already know how to do this, how to hand a value to a function. Everybody used array maps before? So it's not, you get the concept? Right? Okay. In this case, we just have an array of one item, so it's going to hand that one item to that function. Okay. Now suppose, we're good so far. Not too fast, right? Not totally over everyone's head. All right, good. Now suppose that we don't yet have the value for our string. All right? We don't know what it's going to be. We know it's going to be something, but we don't have it yet. Suppose we need to get it. We don't know how to get it. Don't know where to get it. We'll know that later when the program starts running. Okay. Something happens, right? Now, let's suppose we have a function that will go and get our string for us. It has to go some distance. It's got to, take some time. But once we have it, then we want it to have our container take the value that it finally got and hand it to the function, just like our map did earlier. Just, it's got to get it first. Right? Conceptually good. Okay. Does that look familiar? What does that look like? It looks like a promise, because we're thenning over whatever value we just got. So right now we've just drawn a line from an array or a container that knows how to hand a value to a function to a promise that is what? Going to be handing a value to our string length function. This is the same string length function that we had before with our map. Same function. It doesn't care that it's used by a promise or an array. It just takes a string. That's all it cares about. Okay? Both of the promise and the array know how to take the value inside them and hand it to a function. Okay. So we just need to change our map to a then, and we can see we're working with a promise now. So a functor that does some bit of work in addition to handing it to its value to a function, that's called a monad. That's all it is. Promises are essentially monads. Okay. See, the thing is, you guys who haven't heard of monads, you guys are like, so what? Who cares? This is like, why is that so complicated? You're going to run, I promise you're going to run into someone and then be like, oh my gosh, these monads, or like, that's so weird. I can't get into functional programming because monads. It's just weird. It's weird. Now you know the weirdest thing about monads is the name. This is all it is. Okay. So like a monad, a promise does a bit of work in order to hand a value to a function. It has to resolve that value before it does that. So, right? So it's got work to do. The work it does is get the value. That's not always the work that a monad has to do, but in this particular case, this particular monad has to get it and bring it back. Okay.
Wait.
Yeah.
Wait. So the promise. So. Man, what?
There's a little cutoff there. Promise E, paren.
Well, no, I know. Are you passing the result function? Oh wait, no, never mind. I got it.
Yeah. For our purposes, this could just be fetch, right? And you've used fetch before. Anything that returns a promise is just a promise. A promise itself is a container that holds a future value. And once it has that value, it'll hand that value to the function that you put in the then. In this case, we're going to add 5. So all monads are functors also. Not all functors are monads, but monads are functors. Okay? So now you know Kung Fu. Yeah. All right. So now I have some questions for you. Do you feel you now know what a monad is? Yeah. I have a hint for you. Follow-up question. Could you explain a monad to someone else? Again, a similar hint. Okay. We're 15 minutes into this. But you already know. We're good. Okay, good. So of course there's actually more to monads than this. But those other bits are not the hard part to grasp. This is the hard part to grasp. Because some people want to say monads are like burritos, or they want to say that monads are just functors in the category of endofunctors. So now you have to learn what functors and endofunctors are. But that's not important. That's just distractions. Promises are not, strictly speaking, monads. But they demonstrate the core principles of monads quite nicely. So that's why we can use them. So if something is described as a monad, you know what to look for. Look for that extra bit of work that container encapsulates. That's how you know it's a monad. That's all there is to it. Thank you. However, lest you think that you are under the impression that, oh, a monad gets a value, that's what makes it a monad. That's an example of a monad. I have a few other ones. The top one there is probably the most common one you will ever run into, the maybe monad. Who can tell me what the bit of work that the maybe monad does, in addition to handing it to a function?
Compare.
To what?
To null.
In this case, null. Null and undefined, right? So it says, if I'm a thing, then I'll hand you to the function. If I'm not a thing, I'm just going to not. Yeah. So I have this log monad. This is kind of, well, I guess it's useful in a way. All this does is it logs the value of handing it to the function. It's not impressive. But it's a monad because why? Because it logs. In addition to handing it to the function.
And it talks like a monad. It is a monad.
That would be true. Yeah. Yeah. And finally, this is a really cool one. I mislabeled this earlier. It's either monad. Either monad, in order to construct an either monad, you cannot actually have, this is going to get weird, sorry guys. You can't actually have an either monad. An either monad must be either a left monad or a right monad. But either one of those will be, it is either is the superset of the two. And you don't know what you have. You don't know if you have a left or a right. That's why we say you have an either.
Is this related to like binary trees?
No. Although I can see why it would look that way. Not quite. I don't know why they call it left and right. If I was making this up on the fly, I might have called it success and fail. Because what either does is, in order to construct it, you first have to have a predicate. And the predicate takes the value and says, all right, you function, you need to just return true or false, like you would with a filter, right? Give me true or false. I give you the value, you give me true or false. If you give me true, I will wrap you in a left monad. If you give me false, I will wrap you in a right monad. That's all. And those are useful for the other things. You don't need to know why it's all useful yet. What you need to know is what a monad is. Because when you guys go out there and like your senior software engineers, they're like, hey, yes, let's use Elixir. And someone's like, oh, I don't want to use Elixir. They use monads, man. And you're like, monads aren't hard. I know what monads are. Right? That's it. Any questions? Yes, in the back.
Present monads just simply and provide a way for them to be explained. to feel superior to other people.
You don't explain it this way to them. You say, monads are just functors in the category of indo-functors. And then, that's a dog whistle for all the other guys. You're like, oh, he knows, he gets it. Or he likes to pretend he gets it. Yeah.
So if promises are not monads, why are they not?
Oh, okay. Why are they not monads? The reason comes down to, in functional programming, one of the main goals is to steer away from side effects. A side effect is anything that is not pure, so anything that happens outside of the function itself, outside of the scope of the function that you're acting on. What a promise does is explicitly acts outside of the function that it's acting on. It goes out into a network and gets something. That's not strictly what makes it not a monad, though. What makes it not a monad is the fact that it is eager in doing that. So the instant you define a promise, it starts working. If to be a monad, it would say, all right, I've got this thing that I'm going to do some work on. I'm going to wait to do that work until you tell me to. So you have a promise that hasn't begun to fulfill yet. Those are called futures or tasks, implemented differently. We don't have those in JavaScript. We only have eager promises. Incidentally, you can make a task, a lazy promise, out of two promises. It's kind of wild. So, yeah. It's cool. It's a cool bit of code, too. Any other questions? If you're sitting there thinking, this is, again, like, I don't get it. Like, I get it, but I don't get it. Like, why is this special? Come back to me in, I'm going to say 3 months. 3 months from now, and tell me you have not run into an engineer who's like, oh my gosh, monads. Like, I can't even. And then tell me then.
That means you'll have to do another presentation in 3 months.
That's fine. That's fine. What's up, AJ?
So, Cory, I think that you've laid this out really well syntactically and semantically. What I would like to see to help me better understand is the practical use case of dog speaks or something like that, because I hear what you're saying, but I am not clear on why it's useful to me from the perspective of a scenario or a use case.
That is an excellent point. And I don't have, so I have been doing functional style JavaScript for a few years now. And one of the biggest things I struggle with is convincing other people to do it. Because it took me a long time to get convinced to do it. I would see these functional styles, monads, other things, and be like, oh my gosh, why would anyone do that? If you were here last time when I did the thing, I had why would anyone do that? I was trying to address that topic.
Well, what I mean is like, so for example, it's like you're a linguist and you're teaching me about diacritics and clitics and subjugation. And I'm hearing the words, and I'm like, yeah, I understand that this is like a circle, and this is like a square, and this is what they look like together. But I need an example like dog is a noun, and diacritics are the dots over an I if there's two of them, or the accent mark in Unicode over an Arabic symbol. Like, I need the concrete thing. Like, if I was running some task in a database, I get a maybe monad that when I execute it is going to give me the value or the error condition. Or if I'm doing this branch thing with the left and right, I would be using this because I'm sorting cats and dogs, and I don't know what's the bag, but once the cat's out of the bag, it's a left monad. Or something like that I can better relate to understand. Because syntactically, I think I get what you're saying, but practically, I'm having a hard time.
I want to address this, but this is also a lightning talk, so I don't want to take it from someone else. Are we?
I'm the someone else. Go ahead.
Okay. Thanks, Aaron. Okay, let me use a couple examples if I can, and this is something I want to ponder on more deeply, and hopefully provide. Next time, if I do something like this again, I can provide this in a more thought out form, but off the cuff. We have a React app at work, And in that React app, we have a couple of different kinds of layout pages. One is an authenticated layout. One is an unauthenticated layout. We have a couple of different pages that could exist either way. You could exist inside of an authenticated layout or inside of a non-authenticated layout. And we use composition to do that with higher order components. Higher order components, okay, something. That's fun. I wish. No. So we created this branch higher order component, which is effectively this. It takes a predicate and gets passed props and says, am I authenticated? If I am authenticated, then I'm going to branch over to the authenticated layout in my composition of components. And if I am not authenticated, I'm going to branch over to my non-authenticated composition of components. And so there's an example of using something like an either. It's not a monad because, as I said, I'm still struggling to get my coworkers to embrace a more functional style. But the concept is similar there with the either. Now, crap, what was the other example you said?
The maybe.
Maybe.
I'm assuming is.
Oh, yeah.
Usually for there's a something or there's a nothing.
Yeah. So who uses try catches a lot? Who likes to program with try catch? Yeah. Why do you hate yourself for one? Try catches. Oh, maybe. Okay. So what if I told you you never had to write another try catch again? You could still have very safe code. Yeah. So the maybe monad provides this. The maybe monad effectively wraps the concept of try catch into this one little thing. And if you have your values inside of this container, your value could be a proper value that you actually care about, or it could be an error. And if you map over with a maybe, like we did with the array, and the maybe monad knows that if I'm, in this case I checked against null, but you could check against an error type. It knows that, hey, if I'm an error, don't even bother passing this to the function. Just skip it and move on. Then what happens is, now all of your code is only concerned with the happy path. And only in one place do you have to deal with the sad path. When it falls all the way to the bottom and doesn't hit any of your functions. And at the very end, you do this last little check. Okay, am I a left or a right? If I'm a right, I'm going to show this error message, whatever bubbled down through all this. It says, something went horribly wrong at this step, please try again. Right? So now all of a sudden your code is just a pipeline of awesome and not interrupted with, oh, hold on, wait, maybe the JSON didn't parse because I got it from a user or from a file system and I don't trust it. So I got to wrap that in a try catch. And then, crap, well, maybe I tried to access this deeply nested property, so I got to wrap that in a try catch. None of that actually matters. You won't even get to the code that attempts to do that because you've already caught that way up there and you dealt with it. Because you're passing maybes down.
Or you can try something and maybe catch it.
How meta. So I think that's a good example of the value of a maybe monad, which is probably one of the reasons why it's used so often. But like I said, I still struggle to get over the initial hurdle with some of my engineering friends to embrace this in a more full way. There is a learning curve, don't get me wrong, you got to get over it. But if you take the time and get over it, you are going to find a much more pleasant environment to work in my experience. So, any other questions? All right, I'm here all week. Thanks, guys.